My dance moves are back. These moves are all I can do, and that's how I groove. So please bear with it, okay, my dear students. Let's build the vibe, let's build the energy. I want to listen to the chorus once again. Loco. The name of the song is Chauffeur, sung by Tro Lennes and Future. Alright, okay, that's it. Building the energy, building the vibe, because before we start something, it's always good to start with a positive energy and a lot of energy, okay? So always start with great energy, so that you don't so that you end with energy. But if you start with few energy, again along the way you get bored, so you may not have the energy to end it. So start with lots of energy and continue with energy, so that even when others are giving up, you still have the energy to go, to push, isn't it? So you keep pushing again, you keep pushing ahead. So always start with tremendous amount of energy, so that you keep on moving ahead, okay? So let's start a class with this positive note. So hello my dear students, I welcome to this class. My name is Benatang Paton, and I welcome you to the classroom where we learn together, okay? So today's topic is properties of ionic compounds. So we are already done discussing the ionic compounds. We have discussed around 5 ionic compounds, okay, starting from NaCl, MgCl2, CaCl2, LiCl, and calcium oxide. So all of those videos have been uploaded. So moving forward, today we'll discuss a very important topic, which is called properties of ionic compounds, okay? So there are 4 properties of ionic compounds that you should know, and this is very important. If I'm not mistaken, questions come from this topic, okay? And then sometimes they make a 5-mark question. If not from the board, definitely by your teacher in your school exam. So your midterms and your end term and your model exams, your teacher will definitely set a question. So a good 5-mark question, like there are 4 points here. So having 4 points, okay, plus the definition of what is ionic compound, okay, so together how much? 5 marks, isn't it? Okay, so this is a very important topic. So today's class is going to be very important, okay? So let's start now. So the first property is property number 1. So property number 1, it is physical nature. Physical nature. Let's discuss on the physical nature first. It has been raining for nearly a week in Kohima, and so even now it's raining outside, okay? So it's still raining. I don't know when the rain will stop. I am told that it will rain till June 5, and June 5 happens to be World Environment Day, okay? In Kohima, the weather these days are very dreamy, okay? One doesn't like to wake up. So I know your condition also, students. You wish to be at home, snuggled in the bed under the blanket, but then, okay, that's what everybody is feeling. But we have to do our job. So you do your job and I'm doing my job, okay? So we all have to do our job. So physical nature, what is the physical nature of ionic compounds? See class, ionic compounds are solids, so they will be hard, okay? So physical nature, you write ionic compounds are hard. I hope I don't need to remind my dear students that you have to watch the video holding your pen or a pencil and a book, okay, so that you take down notes, okay? Remember that. So ionic compounds are hard, okay, are solid. Let's write first solid, are solids, okay, and they are, since they are solids, they are hard. Here's a question for you, my dear students. Why are solids hard? What is the answer for this question? Why are solids hard? Solids are hard because, okay, because of the rigid structure. Okay, there is no gap between the molecules, between the atoms. So because of their rigid structure, okay, they are hard, okay. So solids are hard, okay. Remember that. So ionic compounds are solids, and since they are solids, they are hard. Okay, that is the first point. Okay, physical nature. Then point number 2, we go to melting point. Melting point and boiling point. Boiling point. Melting point and boiling point. So melting point and boiling point, let me change the marker. So melting point and boiling point. What is melting point and boiling point, class? What is melting point and boiling point? Define melting point. Define it for me, class. Define melting point. Define melting point. What is melting point? Melting point is the temperature at which a given substance melts. Okay, and boiling point, what will be the boiling point? Just change the word melting now to boiling point. So if melting point is the temperature at which a substance melts, then boiling point will be the temperature at which a substance boils. Okay, so very simple. If you want to write it, you write melting point MP. Okay, is the temperature. I'll just write in short. Okay, at which, because this is not relevant. Okay, we are not supposed to be studying the definition of melting point and boiling point. Just to help you build your give you more knowledge, melting point is the temperature at which a given substance melts. Okay, and boiling point, my markers, they don't have ink, that's why they're making so much squeaking sounds. I forgot to refill it. Okay, I should have refilled it. Boiling point is the temperature at which a given substance boils. Okay, so these are the definition of melting point and boiling point. Now we are to discuss the melting point and boiling point of ionic compounds. So what about the melting point and boiling point of ionic compound? Melting point, what do you suppose the melting point and boiling point of ionic compounds will be? Will they be high or low? Okay, before you answer this question, remember the above point. Okay, there are solids, and then the molecules, and the molecules are tightly packed, and the molecules are tightly arranged like this. Okay, now remember this, that ionic compounds are formed. Let's take an ionic compound, for example, NaCl. NaCl. You already know that sodium is a positive ion and chlorine is a negative ion. Ionic compounds, okay, are formed because of the intermolecular force of attraction between a positive ion and a negative ion. So the force between an ionic ion is that of a positive and a negative. Now remember, class, that it's not easy. Okay, it's not easy to remove a it is the force between a positive ion and negative ion is not to be taken lightly. It's the strongest bond. I already gave you in the previous video that ionic bond is the strongest bond, okay, existing, at least in our world. Okay, so ionic bond is a strong bond. So having a strong bond, the force of attraction between two molecules, okay, will be very, very strong, tremendously strong. Okay, so now you tell me, melting point, will it be easy to melt an ionic compound? Will it be easy to melt an ionic compound? No, is it not? So since the answer is no, ionic compounds will have high melting point. So melting point, okay, melting point, you write ionic compound, IC, ionic compounds have high melting point. Okay, very important. Ionic compounds have high melting point. What about boiling point? Boiling point. Okay, boiling point. Boiling point is also same. If ionic compounds have high melting point, okay, then ionic compounds will also have very high boiling point. So both the melting point and boiling point of ionic compounds is high. Reason is because of the strong intermolecular force of attraction which exists between the two, okay, between the two ions, sodium ion and a chlorine ion, between the positive ion and a negative ion. Here I am taking the example of NaCl, so it will be wrong of me to say. But then remember, it can be anything, but it can be any element, okay, but then it is always between the positive ion and the negative ion. Okay, so the force between the positive and the negative ion is the strongest, so it's not easy to break it. So melting point, okay, to break the bonds, not easy. Boiling point, again breaking the bond, not easy. So boiling point also tremendously high, very, very high. So boiling point, ionic compounds have very high boiling point. Okay, so this is the second point. Okay, now we will go to the third point. The third point is solubility. So what about the story of solubility for any compound? What do you mean by solubility? Solubility is the property by which it will dissolve. Okay, so what do you think ionic compounds, what will be the story of solubility for ionic compounds? The solubility of ionic compound, okay, ionic compounds can dissolve easily in water, but ionic compounds do not dissolve in organic solvents like kerosene, petrol, etc. Okay, so solubility, ionic compounds can easily dissolve in water. Okay, ionic compounds easily dissolve in water, but they do not dissolve. Okay, they do not dissolve, but they do not dissolve in organic solvents like kerosene, petrol, okay, etc. So this is straightly taken out from your textbook. Okay, if you open your textbook and read it, you will find these points. Okay, so the first 3 points are done. We have one more property to discuss. So let me go to the fourth property. So these properties that I've discussed are already mentioned in your textbook. If you study your textbook, it's already there. So always develop the habit of referring from the textbook. And being a class 10 student, my dear students, okay, you should study the textbook now. Okay, you should study the textbook. A student of class 10 should study textbook. If you ask me, I also started reading the textbook in my 10th standard. Before my 10th standard, my teachers kept telling me to study the textbook, but then the notes were already there, so it did not strike me to study the textbook. But in class 10, okay, since there was constant study, I had a good study routine, so studying, the notes got over, and then I got time to study the textbook, and it really helped. So studying the textbook is a good habit, and you should also start. Okay, a class 10 student should study the textbook if you want to score more. Okay, if you want to score more, study the textbook. This is to all of you, my dear students. Study the textbook. Okay, study the textbook. If you have not started, start. Okay, start very soon before it is late. The fourth point is conduction of electricity. This is a very important point, and we will have to spend some time explaining this. Okay, so conduction of electricity. So the question here is, class, do ionic compounds conduct electricity? If you ask me this question, the answer is yes as well as no. When is it a no and when is it a yes? Let's try to understand that. See, ionic compounds, okay, do not conduct electricity in their solid form. Remember this. So remember, ionic compound, IC, okay, do not conduct electricity. They do not conduct electricity in their solid form. Very important. Ionic compounds, they do not conduct electricity in their solid form. What could be the reason? See, class, in order for current to be conducted, in order for conduction of electricity, we need free electrons. We need electrons to move. Okay, but ionic compounds, because of the existence of strong intermolecular force of attraction, because of the strong force of attraction between the atoms, okay, there is restricted movement. Okay, so movement is very restricted because the bonding between the atoms are very, very, very strong. Remember, it is the strongest bond. Okay, it is the strongest bond. so there is no movement, there is zero movement. So electrons cannot move, thereby ionic compounds in their solid form, they do not conduct electricity. Okay, so then will they ever conduct electricity? Like I told you earlier, it's 50-50. Okay, in the solid form they do not conduct electricity, but they will conduct electricity in their solvent form and in their molten state. Okay, so ionic compounds do not conduct electricity in the solid form, but ionic compounds conduct electricity in their solvent form and molten form. Okay, so let me explain this one. Solvent form means solution form, in their solution form. Okay, and molten form means in their heated form. Okay, when they are heated. So let me explain to you. Let's talk about this solution form. So remember here, the ionic compounds are in their solution state. For example, NaCl, sodium chloride. Okay, NaCl. This is the common salt, that we which we put in a curry every day. Okay, in Nagamis it's called nimok. Okay, so common salt. Now sodium chloride solution, we can easily prepare sodium chloride solution. Okay, so we prepare a sodium chloride solution, NaCl. Okay, and then we take some apparatus like this. Okay, let's say this is the NaCl solution, Na plus Cl minus solution. Okay, then we take two electrodes. These are called electrodes. Okay, electrodes, electrodes, electrodes. Okay, this is part of electrochemistry. So we take two electrodes. This is electrode, this is also another electrode. Okay, then current to pass, plus minus plus minus plus minus. Right, then this is the plus, is not there. This is the plus. Okay, this is the plus, this is the minus. Okay, positive current comes here, so this becomes a plus. Negative current comes here, so this is a minus. The minus is the cathode, so this becomes the cathode. So this is the cathode. Write cathode here. Let's write cathode. Do I have space here? This is the cathode. Okay, and then this is the positive terminal, so this is the positive electrode, sorry. So this becomes the anode. The positive electrode is the anode. Okay, now well, there's a battery here. This is a battery. So current, okay, current flows here first to the anode, and then from here, okay, okay, what will happen? See here, this is a positive sodium ion, is not? Positive sodium ion, it will be attracted to the negative electrode, which is the cathode, and this is a negative ion, is not? It will be attracted to the positive electrode. So there will be all the sodium and chlorine molecules here will be moving. There will be movement. There will be moving. Okay, there will be movement of ions. So here movement of ions takes place, and it is this movement of ions which brings about conduction of electricity. All right, class. So in their solvent form, okay, in the solvent form, what happens is that the sodium ion will move towards the negative cathode, and the chlorine ions, which are the negative ion, this is called the anion, this is called the cation. Remember, this was discussed last time. So Na plus is the cation. I've already told you how to remember this, not to get confused. And Cl minus is the anion. Okay, if you want to learn, you go and watch the previous video. It's explained there how to remember which is cation and anion. So sodium is the cation, so the positive ion moves towards the cathode, the negative electrode, and the negative ion moves towards the positive electrode, which is the anode, and thereby movement of ions is there. Whenever there is movement of ions, whenever there is movement of anything, okay, electrons or ions, whatever, current conduction will take place. Okay, so here current conduction will take place. Reason is given here because of movement of ions. The movement of ions brings about conduction of electricity. Okay, so this is how ionic compounds in their solvent form conducts electricity. Now what about in their molten form? In their molten form, in their heated form also, ionic compounds will conduct electricity. Let's see how. So let's say let's take our sodium chloride again and let's heat it. Okay, let's give a lot of heat. Okay, say about 700 degrees centigrade. 700 degrees centigrade. That's tremendous amount of heat energy, isn't it? So, okay, then what we'll get molten NaCl. So we'll get a very hot NaCl. Okay, so this NaCl is very hot and having so much heat energy. It is already in their molten form. Example of molten, if you ask me, sir, give an example of molten substance, I'll tell you lava. Okay, lava underneath the volcano, there's hot lava, isn't it? Okay, Iceland. Okay, Iceland, there in Iceland you have lava. You can see the molten lava. Okay, so people go and then they see the hot molten lava. So the name is Iceland, but it is filled with lot of volcanic mountains. Okay, so the names are very misleading, isn't it? So molten NaCl, okay, that means melted. Okay, it's already in liquid form, but it is because of the tremendous amount of heat energy which it carries. Okay, so molten NaCl. Okay, so molten NaCl also will conduct electricity. Okay, how is it that molten NaCl is conducting electricity? Now the answer is very simple. See, when particles absorb heat energy, what happens to the particles? When particles absorb heat energy, say for example this particle is there like this, then let's say these 3 particles, okay, or these 4 particles. Now this is when they are cold, but when these particles attain heat energy, what happens? They will start vibrating, because they will see the heat energy which they receive makes them restless. They become restless. Restless means they get kinetic energy. They want to move because now they have received suddenly heat energy, isn't it? So receiving heat energy, they become hyperactive, they become restless, and thereby they start vibrating about their main position. Okay, they start vibrating about the main position. They start vibrating up, down, left, right, isn't it? They start vibrating. So what happens? They start moving, and when they start moving, what happens? The gap between them will increase. Okay, the gap between them will increase. All of them are becoming restless. This one also becoming restless. This also becoming restless. This also becoming restless. This also becoming restless. All the 4 atoms are becoming restless. Thereby, they will start vibrating. So when they vibrate, this particle will push him, then he will also push him, then the third one will also push him, the next will also push him like this. See, this size and this size, see, big difference, nah? Okay, so this, okay, from this to this, how can it go from this to this? It can only go from this to this when they have attained heat energy. So on attaining heat energy, what happens? The gap becomes more. Previously, before they attain heat, they were like this. Okay, but after receiving around 700 degrees of heat energy, they became loose like this. And now they can go like this also. They can go like this also. So they can move freely, and taking advantage of this, okay, now what will happen? Current will flow, because now there is movement, there is space available for electrons to move. Okay, so now current conduction will take place. All right, so it is because of the availability of space. Okay, now since space is available, free electrons can move. Okay, electrons will move, and so if electrons can move, that means current can be conducted, and that's how molten ionic compounds will also conduct electricity. Okay, class, so that's it. Okay, that is the topic for today. So I hope you understood. Okay, the topic today was not very difficult. We were discussing about the properties of ionic compounds only. Okay, we started with physical nature, then melting point and boiling point, then the solubility, and finally the 4th point, which is conduction of electricity. If at all, okay, students find difficulty, it is this topic. Okay, it is this conduction of electricity where they have lots of doubt and lots of confusion. But I have tried my best to clear the confusion. Remember, ionic compounds in solid form, they do not conduct electricity because of the strong interatomic force of attraction between the two atoms, okay, between the molecules, but in their solvent form and in their molten state they conduct electricity, and the reason has been explained to you. Okay, so now before I leave you guys, okay, I have a question for you, so please answer the question, okay, and please answer the question in the comment box. Some of my students, they are continuously participating and I'm very happy. Okay, the questions that I ask are to let you do self-study. Okay, so the question for today, let me write it down here. So today's question is, it's similar to what I asked yesterday. If I'm not mistaken, in the previous slide I have asked one question. So the question is, yes, the atomic number of an element X is 19. The number of electrons in its ion X plus will be option A 17, option B 18, 19, 20, and finally 21. The atomic number of an element X is 19. The number of electrons in its ion X plus will be 18, 19, 20, 21. Okay, class? So, okay, class? Thank you all for tuning in. Okay? And keep watching this video and keep learning. Okay? These videos are delivered and these videos are uploaded just for you to learn. Okay? So, learn as much as you can. Okay? And then keep studying regularly from your end, because the more you study, the more you learn, and the more smarter, brighter, okay, and effective you become. So on this note, we'll end the video here, and I'll see you again in the next video. God bless you all.